So you can see like in at this United States system, there is no syllabus per se, right? So each teacher, each professor creates their own syllabus based on what works. So we have some flexibility, not too much, to emphasize something and not emphasize something else based on your feedback. And I'll be more than happy to answer more questions like we did before lunch, or we can kind of flip through the slides and see whether something catches your attention. So which way you want me to answer some questions? Any more? No? So we can, this tutorial is a continuation of Design for Six Sigma, and that typically people call as DFSS. So a lot of these things we talked before, that why we do Six Sigma. Again, this is a little bit older technology where they use the word defect. Today we don't even use the word defect or failure, because the defect is a relative word, right? Failure is a relative word. So rather than using defect, most of the new books in quality, they may use the word non-conforming. That means it doesn't conform to somebody's requirement. Not that it is defective inherently, because when you say defective, that is a very strong word, as if inherently something is defective. But it is defective for one person, and maybe it is very good for another person. So I think these slides we have shown several times, so we can kind of skip through those. So there is a concept called, this one we didn't show, the shift in the process. And there is a metric called a process capability. So the idea in manufacturing these days is that if the designer has some requirement, then you have to decide how capable the process is. And there is a very simple equation that one can develop. Then I can give you a little bit motivation of that equation. So it's little mathematical, but maybe you can relate to it. Let's see if I can get a marker. So supposing there is a characteristic x, so this axis is x, and then we have specification limits. So this is lower specification limit, this is upper specification limit, and then there is an ideal value that is the target, or we could use it x rather than y. So x0 is the ideal value that you want to hit. And then I have a process, so my process maybe is something like this. So then people say how capable this process is. So you can see this is very capable relative to the lower spec, but not very capable relative to the upper spec. So then we could develop capability index relative to the lower spec and capability index relative to the upper spec, and then take the worst of the two. So the way we define capability is, so like in this case, the average is somewhere here. So this is like your x bar. X bar means the average. And then you can look at 3 sigma limits. So these are the 3 sigma limits. And then you can look at 3 sigma limits on the other side. So capability relative to the lower spec will be the lower spec distance from here up to here, and then you divide it by 3 sigma. So if this distance is greater than 3 sigma, then your capability is more than 1. Then people say, oh, that is capable. But here distance from here to here is smaller than 3 sigma, so then your capability would be less. So then people develop an index like here called CPK index. So then the mathematical definition is CP subscript K is the minimum of 2 capabilities. It's minimum of X bar minus lower spec divided by 3 sigma. And typically in statistics we can put carets. Carets means what? Estimators. They are estimators. They are guesses. So this is a guess, and then we can put in caret. And then other is this number, or the other number is upper spec minus X bar divided by 3 sigma. If there is no drift in the process and the process has the 6 sigma capability, so then you can see this distribution has a capability of 2, because you look from here to here, it is 6 sigma, then you divide 6 sigma by 3 sigma, so your capability is 2. But if this process drifts by 1.5 sigma, so then this is 6, here is 1.5, then this distance is 4.5. 4.5 divided by 3 is 1.5. So then in 6 sigma, they always assume the worst case that you have a 1.5 sigma drift. So that means your process capability then is just 1.5. So you are happy with that. And then that's why when we calculate 3.4 defects per million capabilities, it is based on this drift of the process. So that is what this is trying to show, that what is the effect of drift. Here you have 4 sigma capability, here you have 6 sigma capability. And I think this slide we talked about before. So this kind of talks about marketing, what is the methodology, what is the process. So like anything else, it is a systematic process. That's one of the principles we use. Focus on the customer, focus on the system, focus on the processes, so that you understand the interdependencies of all the components in the subsystem. And then the tools that we can use in 6 sigma are statistical to collect data, but we can use all the engineering principles to improve the quality of the underlying process. Then we talked about steps like define, measure, analyze, improve, control. So for every project, you can say what kind of things you have to do during measure, what kind of things you have to do define, what kind of things you need to do for analyze. Some methods like ANOVA. Anybody knows what ANOVA stands for? Analysis of variance. So that was developed in 1920s, almost 100 years ago, by Dr. Fisher. So basic idea is that if you have a lot of inputs and you want to do Pareto analysis, so which input changes the output the most? So with ANOVA, we can figure out what are important contributors, right? So like you could say in India, you look at some quality characteristic and then you say, where should government focus the most? Like in this university, Vice Chancellor says, let us improve quality, but which cause we should first focus on, then second cause, then third cause. So that we can do that through experimentation. This word stands for failure mode and effect analysis. So and later on, when we talk about reliability improvement, we can talk about many methods that designers can use to improve reliability. And then this is little more. It says questions to answer in a Six Sigma project. What questions you ask at the define phase and measure phase and analyze phase and improve phase and so on. So this is little more. Then many companies, the way they implement is that you first teach some people. So they have very basic training in Six Sigma. Then you do projects. So if you do 5 projects, then they'll say, oh, you can get green belt, and then you can get black belt. And if you do a lot of projects over 5 years, then you can be a champion in the company. So people use all kinds of words like who is the champion of promoting Six Sigma in a company, or who is so next level would be master, black belt. These words are borrowed from what? Karate, right? Karate. So they use black belts and so on. Yeah. And then you could have a black belt, and then you could have a green belt. And then typically this is a teamwork. So remember, that was one of the principles of collaboration. So you always have finance people, because finance is important too, right? At least in private companies, money is a very common denominator. Who's the owner of the process? So many companies, typically like GE or Motorola or many companies that make microprocessors, they have a way how they will implement the Six Sigma model. So like this is one example from Celestica company. So then the question is, what are some of the things that they do in the organization? What are their overall company matrices, and then how they train people, and how they pick projects, and how they wait for the results, and then continuously improve the quality. And I think we went through that. We covered these ideas briefly. So this can be, you can then make a block diagram for the measure phase. Like we talked about what is important and how to measure it. So it says, oh, that's a pretty complex process. For example, the process is stencil, a print process. So then you can start from some place, then keep on expanding it to figure out which characteristics of this process are important. So these figures kind of gives you some idea of the level of details that you'll have to go through. If you want to apply it to education, you can again study how a student flows through the university over 4 years, right? We can make a flow diagram, and at every step what the student goes through, what we call as toll gate. Toll gate is like what exams the student has to take, then how you get promoted to the next level, and the next level, and the next level. So this was the idea of an example of, what's the name of this figure? We call it fishbone diagram. So one Japanese person, people say he's a quality guru. All he did is teach people 50 years ago that focus on cause and effect. Ishikawa, Dr. Ishikawa. So you see, oh, that is so simple. What is big contribution? But it changed the mindset. Old mindset in quality was to look at the output. With promoting this, slowly people accepted the idea that rather than looking at output, you should look at input or causation. And you can see that mindset was very hard to change. Then you have measurement using gauges and instruments. So then we can always do analysis of variance. So this is an example of analysis of variance, saying if I'm measuring, somebody says, oh, measure the length. So human being is going to measure it. You have an instrument to measure it. So every time you measure the length, you'll come up with a different number, right? So then what part of the measurement is the person and what part of the measurement is the instrument? And then maybe you can train the person to reduce that error. An instrument means that you have to improve the design of the instrument. But rather than just saying is, anytime there is a quality problem, old idea was people just blame other people because they don't understand it. But through scientific, we can figure out which thing is contributing the most. So we can do priority analysis. So you can do control charts. These are called like statistical control charts. These are some examples. You can do, this is like what we learned here, a process capability, right? So then your data is blue, then you can fit a Gaussian distribution, and then you can try to estimate the capability of the process. Another concept that people use is the notion of hypothesis testing. Maybe if we have time tomorrow, we can maybe go a little bit detail in terms of this is really what science is all about, is how do you test the hypothesis. So all of these, the design of experiment is based on Fisher's contribution and how we make the analysis of variance. So we teach like separate courses. Even in your university, there may be a course on design of experiment, and you could qualify it statistical design of experiment. Almost every engineer or every scientist philosophically has to take this course. So typically in a big university, there may be 8 departments who may teach that, because it is so common in science how to do experiment and how to analyze where the variation is coming from. Then you can always like do the control. That's like monitoring over time through a control chart. People make, when you do process flow diagrams, so people do all kinds of input-output analysis. You have inputs of suppliers, output of customers, then you have in-between processes. So you can then keep on expanding this kind of pictures from suppliers. Then you can talk about all the internal customers. So the word customer means is that this person, whoever is managing this process, is the customer of this process. The basic idea is the same. So you could have internal customer or an external customer. Then you can rank a different group. So like if you have 20 suppliers, you could say who's the best supplier, then second best, and second best, and so on, based on a different quality matrices. So this gives you some idea like what are the key project characteristics. So similar, like if you want to pick a project in education, you could say what are the key project characteristics. So it will reduce actual spending, it will avoid costs not currently incurred, and so on. And this again reinforces green belt. So then somebody says what kind of training a green belt should have. So he says a green belt has to learn basic statistics. This is like normal distribution, z-score. They have to understand about probability. they have to understand about how to plan a project. They have to understand cause and effect, failure mode analysis, process capability, like this kind of an equation, measurement system, regression analysis, and on and on. How you test for normality. Then what are some of the statistical, graphical techniques? Then you like analysis of variance, then more advanced design of experiments, and then like control charts and so on. So then you have a list of methods that you teach each employee. Even in India, like we have a Society for Quality or American Society for Quality, they certify people whether you are green belt. So you can pass the certification like as a professor or even as a MTech or BTech student. Then many companies would hire you because now they know that not that you're the smartest person, but you have met some minimum standards. So if I hire you, I know that you have some knowledge of these skills. And typically the salaries are quite good if you can market yourself even as a young person, green belt in Six Sigma. So then locally many companies maybe they say, oh, quality is always important. Nobody will say quality isn't important, right? And then if you have a certification, it is very similar to like you have an MTech degree or BTech degree, but then you have a professional certification that you can do these kinds of projects. So that's a pretty good way to market yourself. You can put it on your card and say, I'm certified green belt Six Sigma person. So this is again marketing. What are the values of a Six Sigma? So then it says every company has a different perspective about Six Sigma. So like GE as a company, then what is their perspective? It says Six Sigma has changed the DNA at GE, how GE works. And then they say, oh, everywhere we focus on these processes in our organization. Then you could do ideas about benefits in terms of cost of quality and so on. So this is just the idea of a picture saying that this is what we teach in a company, and then slowly you can institutionalize it. So the word institutionalization means that you make it permanent in the organization. It is not something you do once, but then you promote this thinking in the organization. Then we talked about design for Six Sigma, and what is design for Six Sigma, how is that different than the Six Sigma. Design always meant is that it focus on the philosophy and approach based on systems approach. Yeah, that was the key idea. So what is design for Six Sigma? And then what are some of the phases when you design for Six Sigma? And then these are a couple of pictures to show you like how people in their company set up phases for design for Six Sigma. So define, measure, analyze, design, verify. And then what are some of the tools that you are using at this phase and this phase and this phase and this phase. This is a design for Six Sigma. We'll use all the basic and advanced design and quality methods. You know this word? Yeah, very good. So that idea is how do you translate customer requirement to engineering requirements? We talked about benchmarking. This is design of experiment. We talked about robustness and so on. So you use all these methods for design for Six Sigma. Here's again a list of QFD and FMEA and so on. You can then always put other qualifiers like we talked about Lean, Six Sigma and so on. The basic idea is the same. And this slide shows a little bit difference between design for Six Sigma and the Six Sigma without the word design. This Six Sigma, you can see that it says that you have a current product or process, and this process has many defects or problems, and then you can apply this. What this means is that you don't even have a current product or a process. Your job is to create the design. So like we learned, is that reliability, robustness is a function of the design. Only way you can improve reliability is by designing in this system. Here it is very hard to improve reliability. Here you can only solve problems. You cannot inherently improve the reliability. So like as human beings, we have certain evolutionary sense, we have a certain reliability in terms of how long we're going to live. But if I don't maintain myself well, of course my life characteristics will go down. But no matter how hard I try, I cannot live to be 200 years or 300 years, right? So my life has been designed in with a certain capability. Only way I can live longer is that if you can figure out how to redesign it, right? And we could say we can do that little bit, simple steps every year through evolutionary processes. So that's the main difference between design for Six Sigma and Six Sigma. The keyword is you are designing to have Six Sigma capability. Other is your design wasn't good, now you're solving problem and you're trying to hit towards Six Sigma. This again is the difference between the two. So that gives you a little more flavor of how a company will implement Six Sigma or design for Six Sigma. Any questions or comments? No?
But in the industry, when we going to implement the Six Sigma, the very good process and goal process will be there.
Yeah, because you need a team leader, you need many people, and then you have to first train a lot of people, and then you give them 6 months or a couple years to implement it. So it is quite expensive, sure. But the idea is that once you learn it on one project, then in future it will be shorter. Yeah, that's definitely. Yeah, that's the basic idea. So then we can go to let's see, we can go to lecture number 9. So that's again like little more emphasis on so safety management. So we have been using quite a bit of the idea for this typo there. So it's like safety management and engineering. So couple of slides we have shown you before. So what typically happens is in like Department of Defense in USA, they use many words like safety, quality, reliability, robustness, and on and on. So question always is what do these words mean? And then you need a very precise definition. So we have been saying is that if you don't have a good definition, then one person says this is what safety is, other person says this. So nobody knows the whole beast, right? So that is the systems approach. It's like you heard that like blind people trying to describe an elephant, right? Everyone has a different idea because nobody can see the whole system. So that typically happens for young people in an organization. You don't know the whole system. You only know your department. So that says if you do that, then there are some quality related problems. So this slide again re-emphasizes that quality is not different than cost or delivery, right? But cost and reliability and delivery, these are some of the qualities of a system. That's the basic idea. Even in America, people don't understand it. So people, even at Harvard Business School in the beginning, people said, oh, there are 7 kinds of qualities, there are 6 kinds of qualities. So this is all garbage because quality has many, many characteristics, not 6 or 7 or 8 or 9. So that is oversimplification. We talked about total versus partial. So in the past they taught you partial, then today we teach you total. Then this is what will I teach you in the future. So this total is an apology saying I made a mistake in the past and we didn't teach you well. But today we have a more systems approach. So then you could say, like any quality, why do we have system safety or reliability? So people try to market that you want to do things within budget, on time, so that things are safe and reliable. Nobody wants to design something that is not safe and reliable. And accidents always happen. We talked quite a bit about these pictures. I can kind of, there are a whole bunch of them. We can skip through those. Even space shuttle, NASA, you can see that any accident like that can be worth tens of billions of dollars. It's very, very expensive. And then a couple of people die. Like simple electronics, people have problems. Laptops, if the Toshiba has to recall laptops, that is very, very expensive thing to do. There was a Japanese company that made airbags, and last year it became bankrupt because their airbags were defective. There was Takeda, so then they almost had to file for bankruptcy because there is such a huge liability. So like airplane, like on an airport, if the computer doesn't work, you have tremendous cost to the society. So we talked about what the word safety is. Typically in English language, people use, somebody says, oh, this thing is safe. So they think it is safe absolutely, like nothing will happen. But that is wrong. There is always a degree of safety. So like I say, I use safety razor. Doesn't mean safety razor won't hurt me, but it is safer than using that knife, old knife, right? That can easily cut you, but razor can make some sharp, cuts too. So it is a question of a degree. So that's very, very important. So it's safety, like we use the word safety match, right? Not that safety match is safe, but relatively it is safe. Relative to other ways to light a fire, it is safe. So this is like one definition for safety. So the key word here is it must do its intended function satisfactorily, and it should be safe. That means safe means it doesn't cause injury, harm, death, or harm the environment, and so on. So it says that safety should be considered as a part of the intended function. I cannot design something that could injure, harm a person or the environment. Sometimes we use the word security. So then you can look for the word security in the dictionary. So question is, what is the difference between safety and security? What you think it is? Safety and security. Maximum level of safety. Yeah. Mm-hmm. 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 Oh, okay, okay. Some people say that you have to look at a system. So they say that we have a system in an environment, which consists of everything, human beings, and the system might be able to have an undesirable effect on the environment, but the environment can also have an undesirable effect on the system. So the key difference is safety is an engineering characteristic because I design it for safety, right? We improve the safety. Security happens is that people outside the system, people who are away from the system, they are part of the environment. Like we have a lot of thieves in the environment, right? So thieves can come and rob your home and break your lock. So when somebody intentionally is damaging the system, those kind of things we call it security versus safety. So like if terrorists come to India and kill people, that is not safety, that is security. Yeah, because these people intentionally come here and harm us. But if a soldier died because the gun or the weapon was defective and this blast killed the person in the field, that would be then safety. But security means that there is a intention to harm this system. So just like you have these days with computer virus, so there are people all over the world who are intentionally harming our computers. So we call it, these are security problems. It's like in the United States we have homeland security, not homeland safety. So homeland security means this is my home, I want to secure it against bad people. I want to secure it. So, which is very different than safety. In safety I could say how it could fail and how it could hurt people. But security, it is very hard to know how somebody will sabotage my system, right? Or how somebody will damage my system. So you can still take steps, but you can design it if you can anticipate how somebody will harm your system, right? If you say, ordinary thieves can break one lock, you can design a different kind of lock for your home and so on. So that is one way to differentiate between safety versus security. Yeah. So you want your computer system to be secure. That security means, of course, you want it to be safe. You don't want it to harm people, but you also make sure that somebody who is not part of your regular environment, they don't come and harm your system, take away information that they didn't have the privilege or they were not authorized to do that. So that is the difference between security and safety. So you can read it further, but the basic idea is the same. Then we can design systems like hardware, fail-safe, or we design many computer systems like computer science. We use the notion of designing fault tolerance system, so that even if something goes wrong, it says fault tolerance or graceful degradation that system still continues to work, maybe even at a little bit degraded fashion. So it is little more tolerant of mistakes that somebody could make. Like Microsoft, when they developed Windows 7, so as soon as you start the Windows, they had two words coming up on the screen. It says Windows 7 is very reliable and very robust. So those are the two words to market the quality of the software. That means this operating system will work, it won't crash, and also it is very robust. That means that even if you perturb it a little bit, you interface it in a different way, still it has the ability to function. So those were very important qualities of the system. So we can make a theoretical, conceptual model between the system and the environment. So in safety, when I design the system output can result in injury or harm. But security means is that something in the environment makes the system go down. Just like a thief, right, or a terrorist, or somebody who is hacking your computer system. So that's the basic idea. Then you say what is system and what is subsystem, and then we could talk about system of systems or interrelationships, like in NASA. NASA is like National Aeronautics and Space Administration or Department of Defense. So you can see there were two ideas that we are using here in designing. Anytime I use the word system, system means that I'm doing a integration, right? Integration, synthesis. But I can only integrate if things are apart, they're distributed. So conceptually, integration is opposite of distribution. Distribution means to diffuse. Integration is to connect them together. And you have to do both. First you distribute, and then you integrate it together and make it a system. So if you can buy 10,000 parts, then you can combine these parts and make a system that does something wonderful. So like you could look at automobile, you may have 100,000 parts, you put them together, and then you have a car. And so then in a company, like we talked like, oh, how can we improve quality in an organization or in India or United States? Many societies, people don't have a common focus. Like we talked, I think before, there has to be a purpose of any system. And then this guy says move in this direction, but this guy says move in this direction. So there's always a conflict. Then what is the purpose of management in system design? Is to align everybody so that everybody moves in the same direction. They say that we want to move from there to here. They said that how can you make, this analogy is like a magnet. So you say that magnet, that means management is providing this electromotive force, and then everything is aligned in one direction. So job of leadership at the top, whether it's in your home or in India or whole world, is figuring out how to unify people so that for certain activities there is a common purpose. And that is the idea of holistic thinking or systems thinking. I think we talked, maybe I talked a little bit too much about China. So this was the world they built, socialism or communism. Communism by definition means communal. You focus on the whole society. America is the opposite. America doesn't believe in system, but we believe in individual freedom. We are free. It's like people are free to carry guns and then they kill other people. And everybody knows it's a bad thing to do, right? Very few countries let people, have guns. But because they are stuck in a model which is no longer valid. So just like anybody can be stuck in any country. So America was founded on a lot of violence, right? Guns, yeah, because we killed all the American Indians and we shot them and we kind of almost killed them out. So people believe that this is the way to survive. But now they don't want to change the Constitution. So that's the problem. So somebody will say, this is written in my book. So anybody, there are two words we use in a political or social sense. One is conservative. And what's the opposite of conservative? You ever heard those words? Conservative and liberal. Liberal. So conservative means is I have some beliefs, I conserve them. I protect them. So I say, this is written in my good book 2,000 years ago, but you cannot tell me it is wrong, right? I'll protect it. This is written in American Constitution, but now you cannot change it, right? So liberal means is that you are willing to go out and change things. Both can be right or both can be wrong. So idea is that should you be open to new ideas or you should stay with the old ideas. So you are conservative. In India they use conservative, right? Yes, sir, that word.
We keep on changing the constitution as per the requirement.
You keep on, that's good, but some people may not be happy. Yeah, that's
people
the idea.
May not be happy, but we can change our constitution.
Sure, America also they can change the constitution. It's not something that they cannot change. But if you're conservative, you want to stick to your tradition. You don't want to change, because if you change, you think you're admitting weakness of your system. Make sense? So you don't want to change it. So like we talked before, a lot of issues that people become very, very conservative. So you need to protect it, but you also need to be open to if things change in society. So then we teach people systems thinking or holistic thinking. It's pretty, that you can teach maybe 10 courses on this. So there is a feed forward, and whether it's something closed loop or open loop. But there are a lot of skills that you can learn for systems thinking, being proactive, and like here it says scientific thinking and creative thinking and non-linear thinking and so on, dynamic thinking. So everything is, there are so many words and methods and tools that you can use to develop systems thinking. And because people get stuck, these are like a couple more. It says, what are the habits of a systems thinker versus people who are not systems thinkers? So system by definition means you're always focusing on putting the pieces of the puzzle together. And you're always looking at everything together. So system focus is very, very important, because he says that many organizations view themselves as composite of independent yet complex components. But the idea of system thinking is that each component has its own set of goals, which may often indirectly or directly conflict other things. But the very fact you are part of the system, now you cannot have this conflict. Both of you have to support the system. Both of you have to support the system because both of you are part of same system, right? So that's the. This is that organizations or society must recognize interdependent relationships among each component and then align their goals or purpose so that they're consistent with the whole system. Many companies have a way, this is what we call as a vertical structure, like you're a CEO, then the president, then all the vice presidents, then managers, and then workers are over here.
Line and staff organization.
I'm sorry?
It's called as line and staff organization.
Organization, very good. So if you are supposing a manager here, then who is your customer? Huh? This person? Both are your customers. So most of the people look at just this line and they say, my job is to make my boss happy, right? Because your boss decides whether you get a raise or promotion and so on. But philosophically, your boss is not your customer, right? Your boss is not your customer. Why? What is the job of the boss? To help you meet the needs of the customer. And then the question is, who is your customer? So you can see, like in a company, if supposing this is research and this is design and so this is manufacturing and this is sales and this is marketing, but the products are not made vertically. Products are made horizontally, because you go to marketing and you talk to customer and then you design something and then you give it to manufacturing, then you give it to sales and so on. So that's the idea, that products are not made vertically, so the products are made horizontally. So now the idea is, if I'm here, I have what we call in the United States, most of the, if you work at Microsoft or Google, they call it as 360-degree review, not by your manager. So if you are here, then, I'm sorry, we can go back. So if you are here, then you do something, like if you're a designer, then your customer is the manufacturing people, they have to make it. And then people that work under you, and then you have to, then all these suppliers, then you are the customer of these suppliers. So the idea is, this person's performance is not evaluated by the boss, but by everybody in the organization. Any low-level worker in Microsoft, they will have a very secured website. You can go to the website and say, this vice president is no good, he's, so you can give feedback about any person in the whole company. So your boss cannot just promote you, right? So just like in university, if you're a professor, your chairman is not your customer, right? So most of the people think my job is to make my chairman happy. But your job is to work, with your students and with parents of the students and with staff and with a lot of other groups in the system. Most of the companies, if you violate this basic idea, and if evaluation is just done by your boss, it can do a lot of damage to the organization. Just this simple idea. It says this is not consistent. So that's why it's like a fabric, an organizational fabric. You need both horizontal fibers and vertical fiber. So that's the basic idea. And then you need old tools and new tools, and so on. Like we talked about, there will always be contradictions. And then you can always develop a systems approach. So very simple is you have input and process and output. This kind of a figure we have been using all week long, right? And then how you can integrate everything together in the organization. So you can see that now we start talking about knowledge. This morning we had a pyramid, right? Data, then information, then knowledge, then wisdom. Very few companies or societies have reached wisdom level, how you manage wisdom. And then top level is more philosophical, that you have perfect knowledge. So you can then expand these things, and then how you can integrate them in an organization. So that is like systems thinking. Then we could say how you apply all these ideas to manage safety in an organization. And here, like we put in 10 points. So it says, what is system safety? Then you could say, what does system safety management focuses on? What are the key processes of system safety management, system management safety? So I think we talked about hazard analysis and so on. Then you could say, what are the roles and responsibilities within the system management safety for senior managers, low-level managers, employees in the organization? How will it benefit any organization, and so on. So you can develop systematically, and the same ideas you can do that for any other quality, not just for safety, right? So basic idea is the same. It's a system safety is not self-regulation or deregulation or a standalone department. It is distributed everywhere in the organization. Just like we say, quality is everyone's responsibility, not quality department. And it is not a substitute for oversight or undue burden, but it is a responsibility for everybody. So there are a lot of information in lot of these documents. When you have course manual, you can put the title of the document, you Google it, then you can print out 200-page booklet on how to do these things. So a lot of this information is freely available. Why is it free? Because in education, like in the United States, it is funded by taxpayers. So anything that is funded by taxpayer, nobody can benefit from it. Nobody can sell it. That would be contradiction, right? If everybody paid and now you are making money which other people paid for. So it is, and then we believe in not just helping America or helping one country, but helping whole human race, right? So you can, there's so much, even people who quote unquote may be enemies of United States can download all this. If you're in North Korea, you can download how to make nuclear weapons, you can download how to improve safety and everything. It is free. You could be in Iran or anywhere. Anyone can download it.
You are having a list of enemies of Americans.
No, I mean every country has their list, right? Yeah. So basically, it is available to idea. That's always a trade-off between freedom and the opposite. Like we talked before about democracy and Chinese system. So China violates this freedom idea. And in China, they even violate to an extent that where they think people are not that smart, to digest this information. So that's why in Chinese internet, they will take away a lot of things because they don't want ordinary citizens to have access to this information. And that, is very flawed thinking, right? Everybody knows that wisdom is that everybody should have the information. You can't hide it, but they try to hide it. And so that is the instinct they have, right? In India, they do that little bit.
You can download.
Pardon?
You can download.
No, I know you can download, but do government intervene some information? They do that, yeah, I'm sure, yeah. But USA, we tend not to do too much, but then it has its own problem.
Government can hide some, but now we have Right to Information Act.
Sure. Yeah, but sometimes they can take away information under some national security issue where they'll say, oh, why are you doing this? They say, no, don't ask me. It is national security, and you're not supposed to have this information. So you can see there's always a trade-off. So we always say wisdom is always in the middle, not this extreme or this extreme. Wisdom is always in the middle. So once you go to the extreme, then you get into trouble. We could take a 5-minute break, then we can go to the lecture number 10, last lecture.